Hello, in this discussion we're going to be using coterminal angles to find the exact values of other trig functions. So let's begin here. So two angles in standard position are said to be coterminal if they have the same terminal side. So coterminal angles are angles that share the same terminal side. So they don't have to, that doesn't mean they're equal. That just means they share the same terminal side. So they give you a couple examples here. In this case, alpha and beta are coterminal on both of these. So if the red angle alpha is going clockwise and the beta is counterclockwise and the other one's going clockwise beta, but they end up in the same blue ray there in that second quadrant, they're not equal definitely, but they are coterminal. And same thing with the next one. If you do alpha, which is counterclockwise to the blue terminal angle side, but then the beta goes around one time. It goes around one time, and then it comes back to that same terminal side. Now, actually, in this case, beta is actually 360 degrees larger than alpha is, but they're coterminal because they share the same terminal side. So what we're going to do is we're going to pick up here is some angles, and we're in some trig functions, and we're going to be able to calculate them. Because what happens is you may not be able to calculate a trig functions at a given angle, but if you can find a coterminal angle to that, then it's possible. Now, I will warn you in the next examples that I'm going to show you here, some of these you're still not going to be able to do because you don't know that one. But I'm going to go ahead and put it down now, but I will let you know some of these that we do here. You still may not know. The first one will be okay. We can do the first one here. You take the sine of 405 degrees. Well, 405 degrees is more than one revolution. So it's going to be one revolution, 360 degrees, and then another 45 degrees. So 45 degrees and 405 degrees, they're coterminal. Okay? So since I know the value of sine of 45 degrees, I can calculate it. It's the square root of 2 over 2. That's one of my special angles. So even though I may not know the sine of 405, I can do the sine of 45 degrees. So because there's a theorem that the author kind of fluffed over a little bit, but what it is basically saying is if you take a trig function evaluated at an angle, it will give you the same ratio as the trig function evaluated at its coterminal angle. So that's what we're using here. Now the next one here, we have a little bit of an issue because cosine of 480 degrees is coterminal to 120 degrees. Now we really haven't talked much about how to find the cosine of 120 degrees because we haven't talked much about reference angles, and we will. But so this next one, when I say cosine of 120 degrees is negative 1/2, it is. But don't worry so much about not knowing that right now. Cosine of 120 degrees is negative 1/2. But this is what I do want you to know. I want you to know that the cosine of 480 degrees is the same as the cosine of 120 degrees because those two angles are coterminal. So you may not know what the cosine of 120 degrees is. You will soon. But right now you just need to know the cosine of 480 is the same thing as the cosine of 120, which, by the way, is negative 1/2. Now, 8 pi over 3, tangent of 8 pi over 3, is the same as the tangent of 2 pi over 3. Now, the tangent of 2 pi over 3, and 2 pi over 3 and 8 pi over 3 they're coterminal. Because what it is, 8 pi over 3 is more than one revolution. 2 pi, also known as 6 pi over 3, is one revolution. So 8 pi over 3 minus 6 pi over 3 is 2 pi over 3. So basically, if you take 2 pi over 3 and go around one more time, you'll get to 8 pi over 3. So to get to the coterminal angle, I subtracted 2 pi over 3. I subtracted 2 pi, which gives me 2 pi over 3. So therefore, the tangent of 8 pi over 3 is the same as the tangent of 2 pi over 3. And right now, that's good enough. But in the future, we'll find out that the tangent of 2 pi over 3 is actually negative root 3. All right? Next one, the secant of negative 9 pi over 4. Well, negative 9 pi over 4 is the same thing as the secant of negative pi over 4, because negative pi over 4 and negative 9 pi over 4 are coterminal. They're basically 8 pi over 4 apart. 8 pi over 4 is 2 pi. So basically every time you spin around again, you're going to get another coterminal angle. Either way, you can either add 2 pi over 3, or add 2 pi or subtract 2 pi, and you'll get a coterminal angle. So what I did was I got negative 9 pi over 4, and I added 2 pi. And if I add 2 pi, well, 2 pi is the same thing as 8 pi over 4. And then I added negative 9 pi over 4 plus 8 pi over 4, also known as 2 pi, and I got negative pi over 4. So taking the secant of negative 9 pi over 4 is the same as taking the secant of negative pi over 4. And at this point, this is all we know, okay? Because we haven't talked much about reference angles yet. So right now, that's all I need you to do to be able to figure that out. But secant of negative pi over 4 is the same thing as the secant of positive pi over 4. Comes later. And that equals the square root of 2. And that one you should know. Secant of pi over 4 is root 2 because cosine of pi over 4 is square root of 2 over 2. So that last equation, you should know that one. Between the second and the third equation, that one you may not know. So the first equation, now you know secant of negative 9 pi over 4 is the same thing as the secant of negative pi over 4. The bridge right here, secant of negative pi over 4 equaling secant of pi over 4 comes a little bit later when we talk about reference angles. And then the secant of pi over 4 is root 2. And that you should know again. Okay? So cosecant of negative 135 degrees. Now, negative 135 degrees is the same thing as going to be, let's see, if we add the 360, okay, so that's going to be it's actually going to be, if you add 360 degrees to that, then you get 225 degrees. So, and then that's going to be the same thing as this one here, cosecant of 45 degrees, but the opposite. I'm doing a little bit of finagling here to make this work. The answer is right. It is negative square root of 2. So, but an angle that's coterminal to negative 135 would be 225. Whoops, sorry. So 225 degrees. So that's a coterminal angle. So and that's going to be negative root 2. So basically what I want, if nothing else you get out of this one here, taking the cosecant of negative 135 degrees is the same as taking the cosecant of 225 degrees. Okay? And if you know that, we're good. We're good. Okay? Now, those last part of these equations, I just put in there because that's what they are actually equal to. We just haven't got there yet. So the main thing for this example I want you to know is taking the trig function evaluated at an angle is not the end all. You can actually add or subtract 2 pi to make the angles a little smaller and easier to work with. So cosine of 480, for example, in part B, it's a lot easier to evaluate cosine of 120 degrees because that's less than 1 revolution. Okay? And not knowing that the cosine of 120 degrees equals negative 1/2 right now is okay. But what I need you to do is being able to figure out that you can take a trig function of smaller coterminal angles and they give you the same value. And that's what it summarizes right here. So sine of theta is the same thing as taking a sine of theta plus 360 degrees times k. That means if you add theta to 360 degrees, you get a really large angle. But taking a sine of theta would be the same thing. It's what we call the periodic. These sine functions are periodic, is what they are. So that's what this is what this is referring to. So, but they have the same value, and k is any integer. Now, if you're reading other textbooks, this is kind of odd for me because I'm used to not using k. I'm used to using n in this example. So I'm used to seeing sine of theta plus 2 pi n. This author here uses k instead of n. So this is kind of odd for me, but k is fine. It's just an integer, any integer. So you might want to pause this, write some of these down. It's not a major trauma if you don't. We'll pick this up again later. But if you can remember those previous examples of what I said, that taking a trig function evaluated at an angle by adding or subtracting 360 degrees to make the angle smaller, that would make it more beneficial and easier to work with. If you can remember that, you're good over here. So that concludes this discussion. If you have any questions on it, let me know. And you have a good day.